So let us see how our script performs on today's Wordle challenge. I've deployed it. The first word it guesses is crane. The next word it guesses is colon. And wow, it gets it right in the third attempt. In this video, I'm going to walk you through how to implement your own Wordle solver using JavaScript. So the correct answer is basically a 5-letter word, and we are given 6 attempts to get that right. So with each attempt, we revealed some clues in the form of green, yellow, or gray blocks. And with the help of these clues, we have to try to get it right. Let us now try to think from an implementation perspective. Before we come up with an algorithm to solve Wordle, let us try answering a few questions first. Say we already have a list of possible answers. Think about what data structure will you use to efficiently store those words and try to have queries like select words that are like this, that are like that start with A and that have R in the fourth position and so on. So like A dash dash R dash. So how would you efficiently design a data structure that is able to answer queries like this quickly? And if it helps, here's a small hint. This data structure is also used for tasks related to autocomplete as well. So if you're able to get that right, congrats. Yes, we'll be using a try data structure here, and we'll have to modify it slightly so as to fit our needs. But a try would do a good job in storing the words, the list of all possible 5-letter words. If you don't know what a try is, that's all right. I recommend checking out a video I'd made a while ago on the same topic, and you'll be able to find a link to it here. You can also try solving this problem on lead code titled Design, Add, and Search Words Data Structure. It's similar to what we'll be doing here, and basically we'll be modifying the try to answer search queries like this dot ad and b dot dot. That's very similar to what we have here, and here dot just means we can have any letter in place of dot, and we'll just need to answer queries if such a word exists in our data structure. So how do we use the clues that we get after every word effectively? So after every guess, the objective is to reduce our search space as much as possible. So ultimately our objective is to reduce the search space to just one word, and that would be it. That would be the answer. Now, using the green clue is pretty obvious. Say currently our list of possible answers contain over 2000 words. Now, from this list, we only keep words that start with a C and has a U in the third position. So we can basically maintain a hash map called correct mapping that shows the correct position of a particular letter. Now, how do we use the yellow clues? There are two parts to this. First, we can eliminate all words in our search space that do not contain the yellow letters. So we can eliminate all words in our search space that do not contain L and K. And second, we can also eliminate words that have L in the third position and K in the fourth position. So given that they are not located here, we can also eliminate words that have L in the third position and K in the fourth position. Thus, it would be helpful to maintain a hash map called incorrect mapping, thus that stores where a particular letter is not located. And now let's say we've guessed the word digit, and it turns out all the letters are now gray. Does this mean we've wasted a guess? Well, not entirely. Now we can eliminate the words that contain the letters D, I, G, and T from our search space. So this can indeed help us reduce the search space further. and we can make use of gray clues as well. So in this case, we can maintain a list of invalid characters, and this can be useful while searching in our try data structure. So now that we have a few things in place, let us start working on our algorithm. Initially, we'll get a list of valid 5-letter words, and we'll add these words to the data structure that we have in place. So in this case, it will be a try data structure. And we want to have a list of good first cases. So this is one such list that's popular. These are choices for popular first cases, and we basically pick one randomly from this list to start with. So that will be our first case, and using the current guess, we obtain clues, and basically with the clues we can update information about letters accordingly. So this is something we need to do from our end. So we obtain the clues, and then we try to store some information about letters, and this updated information can help us to search for the next list of possible guesses, and using our data structure. So using the try, we can obtain the next list of possible guesses, and we'll have to make sure it obeys uh, the information we have in hand. Like, let's say it uses all the possible valid letters, valid positions, and so on. And once we have a list of next possible guesses, we pick one randomly from this list again, and we then repeat steps 3 to 5 until we've guessed the word right. So that was basically a gist of the algorithm. Of course, it'll start to make more sense in the code walkthrough section. So here's my implementation in JavaScript. First, I've defined my list of possible answers, and this will be my search space. And I got it from the source code, and you can keep an eye on this in case it changes. And if it's in case they decide to hide this in the future, you'll have to replace this list with the list of all possible 5-letter words that can be the answer. So let's go to our implementation. So initially, I have a session, a Wordle session object. I've created it, and I've also defined a word dictionary object, and I've passed the session object to it. So this word dictionary. So the Wordle session class helps us store information about the characters, and it updates information after every guess that the script makes. So basically, this fetch word info and update, what it does is for every guess that the script makes, it tries to get the clue from the page. With the help of that, you can obtain the evaluation. Basically, if it is present, or if it is absent, or if it is in the correct position, and it just updates information about that. So that's the purpose of this method. And what is this document.getElement by tag name game app? So so as you can see here, there's a tag called game app, and let's try fetching that from the page, and you'll see that this tag has an array called evaluations, and it contains basically the clues for every guess, and that can be used to update information about the characters, like what characters are valid, their respective positions, and so on. It also has this variable called game status, which basically tells you whether the game is still has to go on, or we are done with it. Also, we'll have to be careful about some edge cases, like the case of repeated characters, where a character can occur multiple times, and in that case, the clues presented to us may have a green block as well as an yellow block. So how will you handle that in that case? Like, you basically do not want to mark it green and yellow at the same time. So So such corner cases may need to be handled carefully. And these are just getter methods, getter functions. And the word dictionary is our custom data structure that is internally a try, a try data structure. And it handles the task of adding words. We basically add all possible 5-letter words from this list to the try. And it will also help us in getting the next set of valid guesses. We basically can use the information from the session object to search through the try data structure and obtain the next set of valid results, valid guesses. So that's the purpose of the word dictionary class and the Wordle session class. The Wordle session is here, and we have the word dictionary class. So initially, I've defined the list of possible guesses to be a list of these, and these are just popular first guesses obtained from the internet. And obviously, you can play around with the list of possible first guesses, since making a good first guess can be important and it can help you get to the answer faster. So I run a loop 6 times. A load attempts is basically initialized to 6, and we make a current guess. So basically, I pick a word randomly from possible guesses, and then using the current guess, I try to obtain clues. I try to fetch clues and then update information accordingly. So the session class handles that. So initially, the state of the word state is going to be 5 blanks, and as and when I get information, the evaluation basically, if let's say the clue is green, and I basically store that information. This is a correct mapping of C is set to I, and I also update the word state accordingly. So as and when information is revealed to me, I store that and I update that in this class. And similarly, if what is presented to me is a yellow block, I basically store where the character is not supposed to be. So this is an incorrect mapping, and this stores where the character is not supposed to be in the case of an yellow block. And in the case of a gray block, the status is absent. I add it to the list of invalid characters. This dot invalid dot push. And finally, I just return if the current guess is the answer or not. This dot is finished handles the status of the game. As you can see here, if this is true, we are done. We can stop guessing. And since we made the changes, we can pass on that. We can remove invalid characters in our data structure as well. So the next time the try searches, it will have less characters to consider. So the try data structure has a list of valid characters, and basically 26 characters, and I filter out invalid characters after every guess. This is as good as a constant time operation, because this is a list of just 26 characters. And then using this information, I try to search through my try, through the try data structure, that is the word dictionary. And then I try to obtain the next list of possible guesses, and this continues. And the next guess is again going to be a random guess chosen from the list of possible guesses that's obtained using the try this time. Only for the first guess, we define the possible guesses on our own, and subsequently, this list is modified by the try. So let's quickly have a look at how the try searches. So this is what the try is going to do. If it is, if the state happens to be a blank, that means I can assign any character that is valid. As long as it's valid, I assign it there, and then I go one level deeper into the try and repeat the process. And the star is the end limiter that I've used in the try. So as I've reached the end of the try, that word can be added. And so basically, this is a method that checks if the word is valid, and it adds it to the search results. Search results is basically the next list of possible guesses. So our next search space. And this can be added method basically does this. It gets the list of correct mapping from the session object. It gets the list of incorrect mapping from the session object, and it basically just sees if the word that we have obtained from the try, if it is present exactly at the location it needs to be present. So that is what this for loop does. The next check is basically if it includes all the all the letters in incorrect mapping. So this is information that is stored on the yellow letters, and if our current word actually includes that or not. So that is one more check. The other check is basically where if our character is present at a location it should not be present, so it returns false. These are just checks that are performed before adding the word obtained after searching using our try. So we've gone through most of the things, and this method enter word basically dispatches a keyboard event to enter the current guess character by character. So this is just a helper method to do that, and then now once it's done entering all the characters, it also dispatches an enter key. So basically, an enter key is pressed as well after that, and just to give it a time interval between successive guesses, I also added a timeout of 5 seconds, since there are animations as well that show up once you enter the characters. So that's about it. Let me first turn on hard mode and then paste my script on today's Wordle challenge. The first case was raise. It then goes with shape, and it got it right in the third attempt. The correct answer was shake. So as you can see, with every case, the search space is decreasing and eventually it gets to shake. So let us evaluate our script now. We have a total of 2315 possible answers. So in every session, I'm going to pick one word from the list and I'm going to mark it as the answer. And I'll just run my script on every one of those answers. So I basically have a for loop here, and I'm just going to evaluate the number of guesses it needs to get the word right. So on every possible word in the list. So let's go. So here's the report. So it was able to guess 2239 words out of 2315 in less than or equal to 6 attempts. And this is the distribution. That is the number of guesses it needed to get it right. So in 2 guesses, it was able to get right 165 words. In 3 guesses, it was able to get right 641 words. And in 4 guesses, it was able to get 823 words right, and so on. Of course, the code isn't perfect and there's room for optimizing it further. But the goal of this video was to help out a beginner who isn't able to come up with an implementation of a Wordle solver. And this is also a really cool way to learn about the try data structure. If you can think of better approaches, feel free to share them in the comment section. The GitHub link to my code will be in the description. Thank you for watching, and I'll see you in the next one.